Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we will be seeing about inheritance in C++. We have already discussed this topic with a briefing about inheritance with regards to object-oriented programming. As C++ is an object-oriented language, we will be studying about this concept in C++, what is the difference it makes, what are the additions to inheritance that we can make use of in C++. So, in today's session, we will be seeing about inheritance and the types available. Inheritance is a sort of relationship between two classes. We already know what is a class. A class is nothing but it comprises of members and functions. So, before we study about inheritance, in inheritance itself there are several other relationships between classes for which purpose we go in for this entire concept of inheritance. So, the relationships that exist in C++ among classes are inheritance, composition, utilization and instantiation. We have already seen about inheritance and instantiation. So, what is this composition and utilization? Composition, it just has the English meaning. Something comprises of something else, something is composed of something else. So, composition relationship occurs when one class is made up of another, one class contains another class. For example, we can have car as a class and engine as another class. So, normally a car is made up of an engine is present inside a car. So, there we come across this composition relationship. Another example that we can take is passengers who travel by some mode of transport need to possess a ticket. Every ticket has its own features, every ticket will have its own details and every passenger has his own identity. So, they can form two different classes, but they are related in such a manner that a passenger possesses a ticket. So, many objects in the real world, like we have seen the examples here, have this kind of relationship between each other. So, C++ provides us an opportunity to depict or exhibit this relationship in the programming domain. So, that is the use of this composition relationship. Next, we have utilization. Utilization also has the same English meaning, where one class makes use of another class or makes use of the details, the functions that are available in another class. So, it is defined as it exists between two or more classes such a manner that one class makes use of other classes. It can be one class making use of two or more classes or two or more classes having the use of just a single class. It depends upon the objects that are involved or the people whom we are trying to represent. An example for this is when you may have a student as a class, a student has his own identity and he performs a function like drawing or painting or coloring making use of a pencil. A pencil also has its own properties. It has a certain length, it has a certain dimension, it has a certain color. Similarly, another person can be a painter or an artist who performs a similar function with the same kind of a pencil. So, here we have two classes making use of a single class called the pencil. So, this is a kind of utilization relationship that we can represent in the programming domain using the C++ OOP. Instantiation. Instantiation comes with respect to objects. An object is an instance of a class. So, when we create an object of a class and say that it is an instance, it is called the process of instantiation. So, it is a relationship between a class and an instance of a class, relationship between a class and an object. Example here is we have this particular object called Maruti which belongs to the car class. We have a particular person who is identified as Donale whose profession is teaching. So, that person belongs to the class of teachers. So, here instantiation is we are assigning one particular object to belong to some type. Here this particular person belongs to the type of professionals who are involved in the teaching practice. So, this is the kind of instantiation relationship that exists between a class and its object. So, here if you see this is slightly different from the previous three relationships where inheritance, composition and utilization all three mostly depict the relationship between one class and another. This instantiation relationship depicts a relationship between the class and its object. So, this is one particular feature that differentiates between this relationship of instantiation from the other three. Now, today we are going to see in detail about this inheritance concept in C++. We have already discussed this in OOP. So, I will just give you a briefing about what is inheritance and how we write programs using this concept. So, inheritance is a property by which objects of a derived class possess copies of the data members and member functions of the base class. So, derived class is a class which inherits from another class and the base class is the parent class. So, here again every class has its own data members and member functions. Data members are variables like integer, float and so on. Member functions are some function that we want the class to perform. So, when one class inherits from another class, it means it gets the data members and member functions of that class. We have already seen that member functions, all of them have a different copy of the member functions, but when it comes to data members, each class has its own copy. So, inheritance is one class getting the attributes, characteristics, features, functions, members, you can use any of these terms from another class. A class that inherits from another class, a class that gets the features of another class is called the derived class or subclass or child class. And a class which is inherited, a class which gives its features, which gives its characteristics to another class is called the parent class or the base class or the superclass. So, you can use any of these terms in an interchangeable manner, all three have the same meaning. So, why do we give so much of importance to this inheritance relationship among classes? So, obviously we see that it reduces redundancy. Redundancy is nothing but repetition in code. Say two or more classes need to perform the same kind of function, you do not have to rewrite the function again and again. You can simply make one class inherit the features of another class. So, automatically those functions also can be used by the class that is inheriting. So, you do not have to write the same function again, or because it will occupy more space, it takes more effort on the part of the programmer and it is boring to anybody who reads the program also. So, this unwanted repetition of data or coding or program is eliminated because one class can use the functions of another class. Easy maintenance of code, the same thing when you have one function defined only in one place, when you want to make some modifications, it is enough if you change the data only in that particular section. Now, if you are going to write the same function again and again in 2 or 3 classes, wherever you have to make the modification, you have to make it 2 or 3 times. So, the maintenance part also is difficult for the programmer, plus if you are going to leave it unchanged, that will lead to some kind of discrepancy between the coding. So, when the programmer is trying to execute the program, he will meet with unnecessary errors and it will take time for him to rectify those errors. So, the maintenance part of the coding becomes easier because we define the function in one place and other classes make use of that same function through inheritance. It extends the functionality of an existing class. This is just this is a kind of advantage that one class which defines a function possesses. Though that class is performing that one function only, because other classes need that particular function, they simply inherit from this class. So, the usage of this class or the significance of this class becomes more than what it was actually defined for. So, because other classes make use of that similar functionality, this class becomes indispensable to the entire program. Moreover, say you are having one class defining addition and subtraction. You want to perform the calculator function on the whole. So, another class, instead of writing the same function of addition and subtraction again, it can simply add multiplication and division, inherit from the class which is implementing addition and subtraction, and thus it will get the 4 important multiplication functions of a calculator or arithmetic functions of a calculator. So, this is how a class's functionality is extended. A class is having one particular part or one particular subtask of an entire process. Other classes can just add the other tasks and they can inherit from the basic class and they can form a process altogether. So, one class's function, though it is not complete, it can be made complete by other functions just adding their small part to it. You do not have to form the entire process, make it a big problem and then solve it. The problem can be easily solved in subtasks. So, all these advantages are present when we use this inheritance concept in C++. So, what are the points to be remembered when we are programming using this inheritance concept? Constructors are invoked in the order of base to derived classes. See, constructors and destructor functions we have already studied. They are also member functions which perform the operation of initialization and destruction of or freeing of memory space. So, when constructors are present in the superclass in the subclass, there will be a confusion to the compiler about when a constructor is seen of the subclass whether to invoke the constructor of the subclass or the superclass. So, there is a particular rule to be followed in that they have to be invoked in the order of base to derived. So, when you are initializing memory, first the base class's data members are initialized, then the subclass. But in the case of destructors, it is in the reverse order. The freeing of memory space is done for the derived classes objects, and then we move over to the parent classes objects. So, these are rules that are already existing and we have to bear them in mind when we define constructors and destructors and when we create objects and destroy them. No constructors, destructors or base class operators are inherited. So, this is another difference between constructors and other functions. When we inherit from another class, only the data members, variables and the member functions which are defined by the user other than constructors and destructors are inherited by classes. Constructors, destructors and operators are not inherited when we inherit one class from another. There are certain access specifiers of derivation. When we say inheritance and one class inherits from another, all do not have the same meaning. In inheritance, we have the importance of the access specifiers. They only actually determine the type of inheritance between classes. Inheritance can be public, it can be protected or it can be private. We have already seen these access specifiers in general with regards to data members and member functions. Now, we will see what is the importance of these access specifiers with relation to inheritance. The public access specifier, the base class here, when you inherit using the public derivation, the base class is visible to anyone who is having access to the subclass. So, because the subclass inherits from the base class, anybody who is having access to the subclass also has access to the superclass. So, everything in the superclass becomes visible to the subclass and to those who are trying to access it. The subclass inherits the members of the base class with no change in the access specifiers of the inherited members. So, what does this particular statement mean? This is the syntax: class keyword, class name, you have a colon followed by the access specifier. You have to mention here whether it is public or protected or private, and you have the subclasses. An example: class keyword, trainee is the name of the subclass. You have the colon, you have the public keyword which is the access specifier, and you have the name of the superclass. And this braces indicate that the braces indicate whatever may be the content of the subclass. So, here we are just having an example. So, I have just given the braces to indicate that contains some code of the class. So, this EMP now becomes a superclass because public EMP indicates that it is being inherited from EMP. So, EMP becomes a superclass, trainee becomes a subclass. So, this is how superclass and subclass are differentiated in C++. The public members of the superclass become public in trainee also. The protected members of the superclass remain protected in the subclass also. The private members of the superclass remain private, that is, they are inherited but you cannot access it. So, however the members are declared in the main class, they have the same access in the subclass also. So, the superclass, whatever features it provides to its users, the same features are provided by the subclass also, there is no change. So, this public is the most freely accessible kind of inheritance in C++. And the method to use this public access specifier is class name colon, use the public keyword followed by the superclass, and you can define the class on your own. There is no change in the access of the inherited members. So, we have seen about the public access specifier and the freedom it gives to its users. We will see about protected and private after the break. Welcome back after the break. We have been seeing about the access modes of derivation and inheritance. We had seen about the public access specifier before the break. So now we will move over to the protected access specifier. This protected also has already been discussed with regards to C+ object oriented programming, but its actual significance comes only in this usage of inheritance concept. Here the subclass inherits the members of the base class, with the public members also becoming protected. So, on the public access specifier we saw that whatever was public remained public, whatever was protected remained protected, but when we use the protected access specifier, whatever was public in the superclass also becomes protected in the subclass. So, there is a change in the access freedom that is given to the members of the base class. There is no other change in any of the inherited members. So, how is this affected in the programming domain? Again, you are having the same syntax: class, class name, access specifier and the subclass. You are having the class trainee over here. You are having the protected keyword instead of public. You are having the name of the superclass EMP and you are having the class definition. So, here EMP is inherited in the protected manner. So, the public members of EMP become protected in the subclass. The protected members of EMP remain protected in the subclass and the private members are inherited, but they are not accessible. So, though there is no point in having a private access specifier, because though it is inherited, the subclass accessors cannot access this private members. So, private is actually useless when it comes to inheritance. So, generally when we go in for inheritance, we either use the public mode or the protected mode. Protected mode gives the freedom to the subclass alone to access the members and member functions of the base class, whereas the public gives all the access both to the subclass and to those who are having access to use the subclass members to access the superclass members also. So, the only difference is the public members also become protected in the protected access specifier. Here the subclass inherits the members of the base class, with the public and protected members becoming private. That means none of the members are accessible. They are all inherited, but they all become private. This is a default access specifier. So, in case you forget to mention the access specifier when you are inheriting or when you are declaring the data members, all the members will become private. That means you cannot access any of the members that are present in the base class. So, we always have to remember that when we inherit, we have to explicitly mention what type of derivation, what access mode of derivation we are inheriting with. In inheritance, it is rarely used. It does not serve the purpose for which inheritance is actually created in C++, because you cannot access any of the data of the superclass. Then what is the point of having an inheritance concept? The same syntax exists for this also. Only thing, you have to replace the keyword as private. Public members also become private here, protected members also become private, private members remain private. That is, all three are inherited, but they are not accessible. So, we will see one example of this inheritance. Here you are having class ex1. This is the name of a class that has been defined. You are having the private data members. One is an integer variable called x. You are having the public members. This is nothing but a constructor. If you see, it is having the same name as the class. So, this is called a constructor function, and here we are simply initializing the data member to 0. And here we are defining a member function, no return type. The name of the function is fn1. It is having an integer variable n. And what are we doing here? This n is multiplied by 3 and we are assigning the value to x. So, this is a function that is defined in this class. Next, you have another function in the same class having the name disp, and we are displaying that value x, that is whatever data member was created in that class, we are displaying it, and then here we are ending the class. So, there is existing one particular class called ex1. It is having one member, integer member x. It is having two member functions, one is disp and the other is function 1, fn1. Next, if you see, we are having this class ex2. This is only called the subclass. Why? Because here we are inheriting using the public access mode from ex1. So, this becomes the base class, that is ex1 becomes the base class, ex2 becomes the derived class or child class, and this is the public mode of inheritance. That means all the members that are public in the superclass can be visible here or can be accessed here. So, how are we going to access it? Before that, we have to see what all is defined in this subclass. We are having the private data member once again, which is an integer variable of name y. So, there we have x, here we have y. Then we are having the public mode ex2, this is nothing but the constructor, and we are initializing the value of y to 0. We are having one function here fn2. Here again it is having an integer variable n. Here we are multiplying that n by 5 and assigning it to y. There we had multiplied the n by 3 and assigned it to x. So, there are two different functions, there it was fn1, here it is fn2. But if you see the next statement void disp, this is the same name of the function that we had used in the previous class also. So, this is called method overriding. That is, you are going to override this disp method with the method that was seen in the superclass. So, when the object of the subclass calls the disp function, it will first call this function only, the function in the subclass, it will not call the function in the superclass. So, this method overrides or it hides up the function of the superclass, that is the meaning of this term method overriding. Method is nothing but a function. So, this function disp overrides or overlaps or hides the function of the superclass. What is done in this overriding function? Here if you see, ex1 is the name of the superclass, we are having the scope resolution operator and we are having the name of the function disp. Now, to call this display function of the superclass, this is the method to be followed in inheritance. Because the same class is defined again, the same function is defined again in the subclass, this function will hide the function of the superclass. Inside this function, to access the superclass's function, we have to use this syntax: superclass, scope resolution operator and the name of the function. So, this will take the control to the display function of the superclass. After that, it will return the control back here. After the display function is executed in the superclass, the control will come back to this statement. The next statement is cout y. That means this y of the subclass will be displayed. So, this is how inheritance works in C++. Now, here the ex2 class is also over. So, ex2 here is a subclass, ex1 is a superclass. Now, we will see how the main function makes use of all these data that are present in the inherited class. So, the compiler starts execution from here, opens the main function. Now, this ex2 is a subclass. Here the object is created for ex2, the class name followed by the object name. So, when the compiler sees this particular function, this particular creation of object, it will call the constructor of the, this is where we have to apply the rule. We saw that constructors are called from the base to the derived classes. So, when the object is created for the subclass also, first the constructor of the base class will be called. So, we have already seen in the base class the constructor, this is the constructor of the base class. So, in ex1 x is equal to 0 is initialized, and then we have to go to the constructor of the subclass y is equal to 0. So, constructors are called from the base to derived, x and y both of them have been initialized to 0. Next, using this object, we are calling the fn1 function. Fn1 function is defined in the superclass. So, this is the importance of the public access specifier. Because this function is public in the superclass, it is accessible by the object of the subclass. So, here what happens, we are passing the number 10. So, this 10 will be substituted for this n, x is equal to 10 into 3, 30 will be assigned to this value of x. So, now x holds the value 30, and then we have ob1 dot fn2 function 20. So, in function 20, instead of this n, 20 will be substituted, 20 into 5, that gives you 100, that will be assigned to this y. So, after this we have to see how these functions are displayed. ob1 dot disp. So, disp function, I told you, it is overridden in the subclass. So, only this disp function of the subclass will be called. Inside the disk function of the superclass is called. So, Cout x 30 will be displayed, then Cout y 100 will be displayed. So, the output will be 30 and the output will be 100. So, this is how constructors, member functions, data members are accessed using inheritance in C++. Next we have types of inheritance. Everything follows the same concept, the same access mode of derivation, but these are all different types of inheritance that we can use in C++. Simple or single, multi-level, multiple, hierarchical and hybrid. I will just give you a diagrammatical representation of all these types. It is better for you to know them, so that because inheritance is only going to go among different levels. Here only two classes are involved, one subclass, one superclass. A single subclass derives from a single superclass. A is the base class, B is the derived class. That is it. This is the simplest form of inheritance. It is also called single inheritance. Multi-level, from the name itself you can identify many levels of inheritance. The derived class of a base class is inherited by another class. So, here if you see B derives from A and C derives from B. So, in one particular section B is the base class and C is the subclass. This B becomes a subclass for the another class called A. So, here you are having two levels of inheritance. Like this you can have 3 or 4 levels also. That is why it is called multi-level. Multiple is more than one class acts as a base class for the other classes. So, here you have C, which is a subclass, it inherits from two superclasses. This is multiple inheritance. Hierarchical is one class is inherited by many subclasses. So, here from this one class A, 3 classes B, C, D are inheriting. So, this is also possible. And in hybrid, from the name itself, it is a combination of 2 or more types of inheritance. Here is an example. First you are having multiple inheritance where one class C is inheriting from 2 superclasses, and the next is multi-level. So, like this 2 inheritance can be combined in one. So, in today's session we have seen about inheritance, its definition, the different kinds of relationship between classes, the definition of inheritance and the access modes, and the types of inheritance. The possible questions that could be asked from this session are the definition of inheritance, the benefits of inheritance like elimination of redundancy, maintenance, functionality, extension of classes. The accessibility modes are the same as that for members, public, private and protected. Protected access specifier is where only the subclass can inherit the members of, can access the members of the superclass. So, all the public members also become protected. So, they are also visible only to the inherited classes. They are not public to whoever can access the subclass. Types of inheritance: single, multi-level, multiple, hierarchical and hybrid. The different types of relationship that exist between classes are inheritance, composition, utilization and instantiation. So, though instantiation is a relationship between a class and its object, this still comes in between classes only, because an object also is of a type class. So, these are the possible questions that could be asked in this session. Thank you.